So resonance can be explained by two different examples that I'm going to give you. I have a seashell, and I would like us to hold it to our ears and hear what we've heard. We've all heard seashells, right? Maybe it might be easier if I have all of you come down here. We're going to turn this around so you can see. Everybody just hold it to your ear. Don't say anything, just listen. So we've all done this when we were little, right? What do you hear? What did you hear? Yes?
Well, it's supposed to sound like the sea.
Did it sound like the sea? Right? It's sort of like hollowy, echoey sound that if you were sitting on the beach, that's what you would hear. And everybody saying the same thing, right? You hear a sea in the seashell, right? That's actually not true. What you're hearing is the ambient noise around you. The seashell is constructed in a very particular way. Every seashell has their own resonant frequency, the frequency that this vibrates at. It's called the fundamental frequency of everything. And what it does is that out of all of these sounds that are around us, listen for them, it picks out one of these sounds and it makes it amplified. And that's what you're hearing. So if the sound, because we are never in isolation, right? We're always surrounded by sound. So the sound that you hear is not the actual sound of the sea. It's the sound that the seashell is resonating at. So it picks out all of these sounds around it, and it is actually vibrating inside the cavity. That's exactly how musical instruments are made. And they pick out what are called resonance. It picks out one frequency and it resonates it. It makes the amplitude of it bigger, and that's what you hear. And every seashell will sound different because guess what? Because of their shape, they all have a different resonating cavity. Okay, thank you guys for coming down. So this concept directly leads us into the resonance phenomenon. So what is resonance? The resonance comes from the Italian word for resounding, or to sound out together with a louder sound. So when you were little, how many of us had like a rocking horse? Excellent. Did anyone actually teach you how to use it? Or we were all on our swing sets, right? When we were little, kindergarten. Did anyone actually teach you how to swing on a swing set? No, right? Most people will say no. You instinctively know how to do these things. Like you instinctively know as soon as you get on a rocking horse that you have to move back and forth in order to get it to move. You instinctively know when you get on a swing, you have to lean back, right, in order for it to go faster. That's one of the things that's fascinating about resonance. We all instinctively know how to do it. It's just we've never put the word to the phenomenon that we're doing. And that word is resonance. And it actually came from sound. It actually came from the acoustical science, which says to sound out louder. You want some sounds to be amplified and you want other sounds to be dampened. And that's what resonance helps us with.